Welcome to Homework Lib.
This is chapter 35, problem number 10. In this problem, we're referring to the previous problem, and we are immersing the system that we discussed in the previous video in water. So now when we immerse that system in water, the wavelength is going to get modified. So previously, wavelength was given to us as 500 nanometers. So we had converted to 500 times 10 to the power of negative 9 meters. And now we know that if we immerse it in water, the new wavelength in terms of the old wavelength or wavelength in vacuum is going to be divided by the index of refraction of water. Index of refraction of water would be 1.33. Now, in all the equations, instead of using lambda, we're going to use lambda naught over the index of refraction of water. So again, if you need to go back to how we calculate the distance between the second and the third dark lines of the interference pattern, please refer to the previous video. So sine theta from the previous video is m1/2 lambda over the slit distance. So now instead of lambda, we're going to put our new lambda, which is lambda naught over n water times d, right? Let me just put W here. Now, if you're calculating the sine theta 1, then our m is going to be equal to 1. 1 plus 1/2. Lambda is 500 times 10 to the power of negative 9 divided by index of refraction of water times 0.45 times 10 to the power of negative 3 meters here. Now, sine theta 1 is going to be equal to 1.25 times 10 to the power of negative 3. And same way if you calculate theta 2, but for this time, we're going to take m to be 2. Then the rest is pretty much the same. 1.33 times 0.45 times 10 to the power of negative 3 equals to 2.08 times 10 to the power of negative 3. Now we're trying to calculate the distance between the second and the third. So delta y equals y2 minus y1 r tangent theta 2 minus r tangent theta 1. Let's go to the next page. So then delta y equals r tangent theta 2 minus tangent theta 1. So we have an approximation here. We're going to approximate sine theta 2 to be almost like tangent theta 2 and sine theta 1 to be tangent theta 1. Then r is given to us as 75 centimeters, so let's convert that to meters. And tangent theta 2, we just calculated it to be 2.08 times 10 to the power of negative 3 minus 1.25 times 10 to the power of negative 3. So what we have for the distance is 6.2 times 10 to the power of negative 4 meters.